Hello, Portugal. Hello. How are you all doing? Excellent. Having a good afternoon? Staying awake after lunch? Well, after kind of lunch all day. I know it's kind of difficult. All right. How many people, this is their first time to NDC Porto? Every hand should go up. My name is Spencer Schneidenbach, and I'm here to talk to you today about expression trees in C#. Not only what they are, a little bit, but how they're used today and how you could use them. Give you some ideas, jog your memory, jog your brain a little bit to give you some ideas how you might be able to use them in your day-to-day. First things first, this is my Twitter. It's at Schneidenbach, and you can find all the slides plus more at schneids.net. Or if you just follow me on Twitter, I'll be doing this a few times throughout the presentation, where I click on this handy little link, and then I tweet out exactly what I'm talking about. So there you go. First things first, tweet out a link to the slides. I have a few code examples in here that use .Dotnet Fiddle, so you're able to hit play in the browser and follow right along, or do it after the talk is over. So let's dive right in and get started. How many people have ever queried a database with a LINQ expression? Something like this, where you're doing a from, where, select, and then you grab a handful of properties. All right, Entity Framework, hands up. Entity Framework, folks, very good. How many people still use LINQ to SQL? Maintaining some kind of, okay, there's a few hands. Very good, very good. Or NHibernate even. All right, so if you've done something like this, then that means that you've probably used expression. Have you ever been asked to do something like this, where you're asked, or how many Razor developers, anybody using ASP.NET Web MVC? Very good. Or ASP.NET Core, where you're able to go into your Razor view and you do and then you do HTML.editor4, and you've created some kind of strongly typed model, and you say, well, I need to be able to type a first name in for this employee or whatever. How many people have done something like this? Very good. And how many people have, in some arbitrary way, for some library at any point, have ever been asked to select a specific member from an object? You give it a type, you give it something, it has a type, it knows that you're looking for the employee, and you give it a lambda, something like this, where you're trying to select just the name. How many people have done something like this? Very good. All right, well, if you've done something like this, you've used expression trees at some point in your C# life, even if you had no idea. So, first thing I'm going to talk briefly about what expression trees are. First, before we can talk about those, we've got to talk about lambda expressions, right? Or lambdas, whatever you want to call them. Something like this. So if you're able to, you could use a local function, you can declare it inside of a variable. If you do something like func of string, which is just saying, I am a function, I take in a string, and I return a string. And then you set it to some arbitrary variable, call it toUpper. And then you're able to actually set it to something like this, where you go string goes into string.toUpper. And what you've done is you've literally just created a method inline inside of a variable. Most of us have done stuff like this. This is probably not news to many of you. Then you're able to capture that and able to go and call that method right there, because it's a valid method at that point. And you're able to pass in an argument. In this case, pass in my name. And what happens when you pass that into that? You get that. You get my name back. It's just capital letters, right? Calling toUpper. Very good. All right. Straightforward so far. So then we declare it again in a different set of code, and this time we don't declare it as func of string. We declare it as expression of func of string. Do the same thing. The syntax is all together pretty much the same. And this time we try to call our toUpper method on our Spencer character, and then what happens? Nothing happens, because it doesn't compile. It doesn't compile because this is, by definition, this isn't a function. This isn't a function in the purest sense of the word, at least not yet. So what the heck do we have? Because what we have here is something that are two things that are syntactically similar. They're syntactically the same. The only difference is the way that we've declared them. And the key difference to understand, if you're trying to understand what a lambda is versus an expression, is that a lambda does the thing. It actually takes the variable, you put it in, you call the toUpper method on it, and it actually does that thing. Expressions describe how the lambda does the thing. It describes exactly what that does. So let's break that down a little bit. So again, we have two things syntactically the same, which is awesome. This is a property known as homoiconicity. And it essentially says that the syntax that we use to not only declare our methods can be used, pretty much almost the exact same syntax can be used to describe methods. So that's a really powerful characteristic for this language to have, and is one of the most important parts of when they introduced LINQ and expressions in general. It was one of the most important things they did, because it makes the development experience natural. If you're using the same syntax to declare inline functions like this, that you're able to use to describe the way that inline functions, the way they are in an expression, that's a really powerful concept because it becomes natural to the developer. It's a really powerful abstraction. Okay, so let's talk about the different things that we can do with an expression. We know that an expression describes a function. It describes a function, and a function does something. Okay, so there's three main uses for them. We can read them, we can create them, and we can use them. Right, so we'll start by talking about what we can do when we read them. So let's take our two upper friend. You're going to see this guy a lot. He's going to come back because this is a pretty rote example, right? So you're going to see him a lot. Our two upper friend. We have our two upper friend. So this thing can actually be decomposed, right? When you've compiled a method, you can't go back and you can get some information about that method. You can get its number of arguments, you can get its return type, and you can't really do anything else, right? So what we can do is break this down into its component pieces. So let's take there's two major sides to an expression, right? There's the left side, which has the parameters 0 to as many as the CLR will support parameters, and then the right side, which is known as the body of the expression. So first thing, what we have here on the left side is we have a property called str. We know based on the way we declared it previously, it's a string. We know that the parameter is a string. So it is a parameter expression, and it has two important properties. It has the type of the parameter expression, which is just string, and it also has the name of the parameter expression, which is str. So when you declare that variable, when you declare that expression in line, the name of that variable is captured right there. All right, very good. So then we have the right side of our expression. We have our body. We have the body of the expression, and this is what's called a method call expression. So this is actually a reference to the string.toUpper method. But of course, string.toUpper requires an instance of something. So of course, it's the parameter. It's just the parameter that we passed in. Okay, so that's pretty much what an expression is. You're able to look and take this information at runtime and do things with it. And we'll talk about what some of those things are. If I were to replace that str on the right side, if I put Spencer in quotes and just called toUpper, this parameter expression wouldn't be used anymore. It would still be there. It could still be inspected, but it wouldn't be used anymore. It'd be replaced with a constant expression instead. So not only can we read them, more on that later, we can also create them. So we can do this like we've done in line, nothing different. And this is really useful. This is really useful because it allows us to use it with our favorite libraries, like Entity Framework or AutoMapper or NHibernate, whatever the things that you use that use expressions, we can use them. We can declare them in line because oftentimes we know those types ahead of time. But there are plenty of times where there's a handful of times where it's really useful to create them at runtime. You can not only declare them in line when you know all the types and all the information in the body of the expression ahead of time, you can also create them at runtime. So this is what that looks like. This is called the expression API. It's really awesome. So let's talk through it just a little bit with a nice example. So we already know that our function is composed, our expression is composed of parameters or arguments and a body, right? And that's true for all expressions. So a parameter expression is a kind of expression that represents the parameters into that lambda, right? Or into that expression. And this is how you declare it, right? So there's no new expression. You don't, new expression to create a new expression. They use the factory pattern. So everything is expression dot parameter or method call, or just in this case, call. So in this case, it's just expression dot parameter, and then it creates a new expression. And we pass it. Its bare minimum argument is that it needs a type. We need to know the type of that expression when we're building it. So we pass in a type. Optionally, we can also provide a meaningful name to that type, in this case, or to that parameter. In this case, my str, we can just send it in with a name. And if you don't send it in with a name, as the parameter is built, it's usually pick something like arg0 or something like that, something with less meaning. Constant expression is another kind of expression like I described to you earlier. It takes a constant, it wraps around a constant, something that's either hard-coded or just read one time, a value that's just stored alongside the expression. So if you do expression.constant, it takes an object in as its argument, and then it just becomes a constant, right? It's not anything, it's just something that can be read. It's something that can be read straight from memory. It doesn't have to be interpreted necessarily. And then, of course, we have method call expression, which is very important. And a method call expression represents a call to a method. So what we've done here is we've taken our expression.parameter, and this is basically building our toUpper, and we'll break through this a little bit. This is building our toUpper thing. But the important thing is this expression.call, where we give it something to operate on. In this case, it's the parameter. And then we give it a reference to the method using reflection. And there's a couple of different, as you explore the expression API, you'll see all the different ways you can find a method inside of a type. But in this case, we just use reflection. We call expression.call, we give it the instance, and then we give it the method that we want to call on that thing. Okay? Well, let's build our string.toUpper. Very simple. We start with expression.parameter. So we've got type of string, and then we want to call it str because we're actually building it exactly as we want it up here. We want to make exactly that expression. All right? Then we get our reference to our toUpper method because we know that we call toUpper on something. At this point, we know we need to capture it. So we need to capture that. We use reflection in this case to just capture it. And then we do our expression.call as I already showed you in the last slide. And then you do this, expression.lambda. So this is the part where you say, you have a body of the expression, you have the parameters, let's glue them together and create our lambda. And that's what this does. And that's it. That's all the lines of code that we need to write to get this toUpper expression. We'll get to why that's useful in just a little bit. But it doesn't really require a lot of code. It's really natural. You can really reason about it. So then not only can you create them and read them, but you can also use them. So expressions can be compiled right in memory and then run just like another method. So after you've called expression.lambda, you've got a reference to what's called a lambda expression. And that lambda expression contains information about it contains the body and the parameter. So once you get to the point where expression.lambda works, because if it doesn't work, it'll throw an exception, it'll tell you it's invalid for some reason, you can call .compile on it. And then you can do dynamic invoke. In this case, dynamic invoke, it does not have any type protections. It just takes a parameter of our argument. So as long as that set of parameters matches the signature of the method that you created with your expression, this will work. But it's not strongly typed. But you can also use them like this, where you can actually call expression.lambda and give it a type argument. In this case, it's func of string and string. And then what you get back is once you do call .compile, you get a lambda expression of type func of string string. And then you can call compile and then invoke it, and it is actually strongly typed. So that's pretty cool. Read them, use them, create them. These are all the different ways that we can do with expressions. All right. Any questions? That's the end. No. That'd be terrible. Because this is a real world talk. I mean, you came here to see some real world. This is about the real world. You came here to see some action, right? You didn't want to just see like how to use the expression API. That's boring. So let's talk about the real world. So we're going to ease into that by talking about some of the things that your favorite libraries do to use expressions. So we'll just two simple examples. We'll do Entity Framework and we'll do AutoMapper, because those are two of my favorite libraries, personally. So Entity Framework, its thing is that it translates those LINQ expressions into SQL, right? It does a pretty good job at that sometimes, a lot of times. But that is its core thing, right? If you're talking to SQL Server, which I use SQL Server with Entity Framework, it's going to translate your LINQ expressions. It's going to translate them to SQL. So this is a sample of what you might call to get that SQL, right? So we've got db.products, which is just representing, which is a DB. If you've not used Entity Framework, it's a DB set, or just an object that represents essentially a table, right? But it's a table in memory, or it's a representation of that table. So then we call .where, and then we just want the product where the name is eggs. We just want eggs. We just want to see eggs. And then we do an order by where we just order by price in a descending order. So we want to see the most expensive eggs first. Okay? Pretty normal stuff. There's really nothing special here. And this is roughly what it's going to generate for you. Now, if you've actually seen Entity Framework's queries, you know that it doesn't emit anything that looks anything like this. It looks way weirder, right? And that's because, it's putting it in brackets, and it's making sure that it can run, and it's making it pretty for Entity Framework. But roughly, this is what comes out of the other end. So you look at this and you say, okay, well, that's great. We have our LINQ expression, and then it translates to SQL. Magically, we get things. But what's the magic in the middle? And it literally just is magic. That's all it is. Or at least it can feel that way. Because a lot of the times, how many people have had an Entity Framework query that they just hated? That they just hated that they actually inspected the SQL and they looked at the other end and they saw, or you got a nasty call from a DBA. That's even better. When the DBAs yell at you for the queries that the Entity Framework writes. It happens. It happens. So understanding what's happening under the hood can actually kind of help you avoid those mistakes. And one of the important things that you need to understand is that db.products is what's called an iQueryable. It's a special type of IEnumerable that can operate on expressions. So they're very similar, but iQueryable has a ton of power behind it. Let me show you. So this is the signature, kind of, for the most part. It's the signature of .where, right? You give an enumerable of t, and given an enumerable of t, you call .where. It takes in a function that's called a predicate. And the predicate takes in the object of type t and returns bool. And it basically says, should this object be returned in this set or not? The queryable, so the enumerable is a static class inside of the LINQ library. Queryable, also a static class, but instead of operating with a function, it operates with an expression. So it takes in an expression of func, of t bool. And that's really important because this one can be interpreted by a library at runtime. And that's exactly what Entity Framework does. It takes this LINQ query, it takes all the stuff in behind it, and it actually interprets it at runtime, right? This isn't compiled. This is none of this, like one of the things that I struggle with when I talk about Entity Framework, or the things that junior developers often struggle with, is the concept that this function is never actually called in most normal circumstances, right? Because you're not calling two lists, you're not loading them into memory first and then operating on them most of the time. Most of the time, this is actually just being interpreted at runtime. Junior developers have a really strange time with that. So I have to go in and explain what this is doing, right? You have to, and I'm sure some of us have had to do that before. So expression visitor is the magic in between. It is the thing in between. It's used to read expressions and operate on them, and sometimes modify them. Let me show you. So given our sample query, our sample LINQ query that we have here, this where clause inside of our LINQ expression roughly becomes this SQL. And that's where the expression visitor comes in. So this expression is known as a binary expression. The body of this expression is known as a binary expression. So a binary expression has three simple parts. It has a left side, it has a right side, and has an operator. Right? So left, it is an expression. The left side of that thing is an expression. The right side of that thing also an expression. And the thing in the middle is called a node type, or an operator, whatever you want to call it. It is equal, or not equal, or greater than equal to, so on and so forth. So expression visitor reads each piece of that expression and operates on it in a different way, right? Its goal is to translate, in this case, its goal is to translate that LINQ query to SQL. So the first thing it does is it reads the left side. It says p.name. Well, I know based on the expression that I'm able to break down that this is a property expression. .name is the property expression. It's the property of the parameter that was passed in, which is a product. So it knows it's product.name. So it knows that it's operating on the product iQueryable, or at least that base thing. And then it looks at that double equals in the middle and it says, oh, I know what that is. That's saying it's equal. It's a binary expression, so I know that in SQL, that's actually just an equal sign, right? And then, of course, you've got your hard-coded eggs, which is in quotes, but SQL doesn't do double quotes. It does single quotes. So your expression visitor implementation is actually taking this and taking it and breaking it down bit by bit and saying, this is the column name of this from this table. This is the roughly what equals means in SQL. And I say roughly because you ever try to compare equal null inside of SQL, it doesn't work. And then, of course, eggs is not in double quotes, it's in single quotes, like JavaScript. All of JavaScript is there, but never mind. So that's the thing in the middle. That's the magic in the middle. Now, you could fill an entire day talking about expression visitor, what its power is, and how to do it. So we're going to go through just a couple of quick examples just to give you a little taste, give you something to kind of chew on a little bit. And it's important to understand that because this is just, it took me a little while to find this. It actually took me a surprising amount of time to find this on Stack Overflow. It's an example of a query that was translated from a LINQ expression, right? This is what it looks like. How many people can read this? We can all read it. How many people want to read it? None of us. So understanding what expression visitor does under the hood, because C# is not the same as SQL, it's just not. So understanding a little bit, just even a little bit of how it translates queries can be really powerful. And that also, funny enough, could fill a day. So expression visitor can be used to read and operate on expressions or modify them, kind of, because expressions, that expression API that I showed you, expression.parameter, expression.call, all of those things are immutable. All the objects that you get out of that are immutable, which is a good thing. But an expression visitor can be used to modify that behavior at runtime if you want it to. Let me show you this one. So this is an example of an expression visitor. And given this expression visitor, when I call .visit, this is a method that you can override. If you implement expression visitor, it has no required implementation. You can implement all the things that you just need to implement. In this case, I just want to say if I visit any expression of any type, I just want to make sure that anything that I call, I want to just type it in all caps. So I have this little protection here. If node type is node expression type parameter, well, you can't call toUpper on a parameter in this particular case and in every case. So that doesn't exactly work. So you have to just return the base thing. But after you get past that point, if your type of your expression is string, because all expressions have a type associated with them, we're going to call the getUpper method. So you can implement this class to modify your behavior. Imagine if you had something where you said, I want to change all the binary expressions. You wanted to mess with your coworker. So you wanted to translate all the binary expressions. If they're ands, just translates them to ors. And then run it in production. And then look for a job. So you can actually follow along. Oh, no, I've got my little example here. Let's walk through this very quickly. So we've got our toUpper visitor. We're just instantiating it, and we have our expression up here. So what we're going to do is call this toUpper visitor.visit and convert. All it does is take that expression and just returns the expression of the same type. And then we're going to console.writeLine, express.compile, then call it dynamic invoke. And then the output of that, if you do that, is the cheese belongs to Spencer. It's capitalized this part, and it's capitalized this part. Pretty cool. You can actually look at that. This toUpper example this is a LINQ, so go ahead and click it. I'll wait. Or you can just check my Twitter afterwards, because this is one of those things. This is using Dotnet Fiddle. I'm going to put that out. Close that. That's happy. And what that is you can go to this toUpper visitor. You've got a little bit of code here, and then you can run it, and you can see that I'm not lying to you. It's just basically copied and pasted from that slide that I showed you, the toUpper visitor, same stuff here, and then if you zoomed in here, it says the cheese belongs to Spencer. You go and zoom in on that for maximum absorption. Ooh, I zoomed in too much. All right, there you go. So that's expression visitor. Again, I could talk about expression visitor all day. You could do a workshop on it, like I said. We're not going to talk about it anymore. The important thing to know is that you have it available. It's a tool inside your toolbox. My boss loves to say, well, let's play with the Legos that we have. This is a really awesome Lego. This is actually like a box of Legos inside your Lego box. So at least you know it's there. All right, AutoMapper. So AutoMapper has a really simple use case for expressions. And this is how many people use AutoMapper? All right, very good. So AutoMapper is like one of my favorite libraries to use because it allows you to do some really cool things. It has a lot of conveniences built in to make our lives as developers easier. So one of its main use cases is just selecting, right? So if given a map between an employee and an employee model, let's say the property names don't match up exactly. So we could say for the member, the source member, the target member first name, we want to get it from the my first name property on our source object. Okay? So we're not going to go through exactly what this is doing. The important thing to know is that the C to C goes into C.firstName and the G.myFirstName, those are expressions. If you look at them, the map from uses expressions. They all use expressions under the hood. And this becomes really powerful when you do something like project to. How many people use AutoMapper with project to? This is like, oh, I like that. There was a lot less hands that time. This is magic. Let me show you. So consider this. You've got a DBA that already hates you because you use Entity Framework. So now you want to say that, okay, we've got this item detail, and let's say it just has like 102 properties on the object. So it has an ID, primary key, a name, and then literally 100 other properties, right? And then you have basically a view inside of a UI that just needs ID and name. It doesn't need any of those other properties. It's just a list of the products that you want, right? So you do something like this. How many people do stuff like this, where you just map it, you just call a mapper.map, you just say, I just want the item detail model, and you just hand it a set of data. If you've done this before, many people, if you've used AutoMapper, you've done something like this. But here's Be the Dragons, because what this is going to do is a select star. And the reason it's going to do a select star is it's going to take db.itemDetails and say, oh, they want the entire set. Afterwards, I will evaluate that and then convert it into item detail model. So what you've done is a select star, right? You've selected all 102 properties, and your DBA is screaming at you and knocking down your door because you're returning way too many columns or doing these expensive queries, and there's no need to do it. That's where Project 2 comes in. Project 2 is one of my favorite parts of Entity Framework, or of AutoMapper. Because what you can do is, as long as you have a map defined, you can call .project2, and you can give it just the type of the item detail model. And what AutoMapper does under the hood is it takes those expressions that I showed you, and then does magic. It just projects. It literally projects that item detail to the item detail model. And it just says, oh, they just want the ID and name property. And the magic is so good because it all does this under the hood, and it works with just about every, and AutoMapper will do this with just about every ORM that uses LINQ. It will say, select ID and name from item details instead of all 102 properties on that object. Super cool. And all you have to do is just instantiate your map. So let's talk about, so we've seen Entity Framework, we know the stuff that magic that happens in between, and then we know AutoMapper and all that magic. And we know that we've used libraries like ASP.NET MVC and Razor that have done all these things. So those are great. So let's talk about my real-world experience. So a little bit of background on me. Usually people start to talk with that, but that's not really that interesting. So this is relevant, so I'll tell you. So I am a software architect for a startup in St. Louis, Missouri. If you look at the United States, it's literally right in the middle. It's a pretty boring place to go. Many of you probably have never heard of it. And it's called St. Louis, Missouri, and I work for a small startup called Rivet. And Rivet makes integration software. So they integrate accounting systems with project management systems, stuff like that. And we had a need, as an architect, we had, I observed actually a senior developer thrust into the architect role, unbeknownst to me at the time. But we needed to be able to create some kind of model mapper. Because what developers were doing to transfer the data, and this was a system as I inherited, as many of you have, and then built on top of, as many of you have, right? It was basically just an ETL tool. It was a really fancy ETL tool that did some magic under the hood. And essentially, when we have something like a Salesforce customer and a QuickBooks customer, we want to map those things together. We want to take a customer from Salesforce and map it to one in QuickBooks in order to do our integration magic and then send that customer all the way up to QuickBooks. So we'd end up with models that kind of look like this, right? Salesforce customer, and it has like property names that are kind of the same, like create date and open date, which kind of mean the same thing, but that's the meaningful thing. That's the meaningful mapping that we wanted to generate. And then, of course, the Salesforce customer has a customer name for some reason, and then QuickBooks. It doesn't really matter. I didn't really care, right? I just knew that they were different, and this happened all the time. So we would write stored procs, or at least my predecessor would write stored procs to move this from one table into a staging table. Essentially, they do an insert statement on the QuickBooks customer, because that's where we wanted to send the Salesforce customer. And we'd say, insert the name and the open date, select customer name, create date from Salesforce customer. And we'd do some checking to make sure that we didn't duplicate date. So we'd write these stored procs. Now do that for hundreds of objects and thousands of properties, and don't ever make a mistake, because then you corrupt data. Okay? How many people write stored procedures as a regular part of their job? How many people are good at writing stored procedures? I'm putting my hand down because nobody's good at writing stored procedures, especially stored procedures with messy things like this. What we found was that our developers were having a really hard time getting these stored procedures written in a really consistent, good way. So we had something that was just, it didn't scale very well, because we'd find mistakes, and we'd often find them when it was too late, when it was downstream and we've already overwrote some customers' data. Not good. Customers do not like that. So I knew, and I'd heard about this thing. I had just fresh off another job. And I turned to my boss and I said, there's a way we can do this better. since we're already talking about entities, we already kind of modeled them in Entity Framework for both sides. We already have the type information that we need. So we can use, I think we can use these things called expressions. Now, keep in mind, at the time, I knew what an expression was. I probably came, like if I had came out of this talk, if I had attended this talk, I would have came out with the same knowledge, probably a little more. But I just knew conceptually what they were and what they could do. And I said, I think we can do this better. I think we could create strongly typed bindings in a way that we could just bind two entities together and just make it generate the SQL for us. And he said, you have 1 hour to do a proof of concept. Okay. Not to brag, but I had something in 40 minutes, which was pretty good. And he said, man, if you worked this well all the time, we'd have everything done like way sooner. And I'd be like, yeah, but then I'd be really tired, and that's not going to work. Anyway, so essentially what I built was a way for us to take, let's say we have SF customer to QB customer. And what we'd have is what we'd call them a SQL generator. Instead of stored procedures, we had SQL generators. And what it would do is we'd give it two types. So we'd have, this example's missing it, but we'd have two type arguments. So we'd say the source object was Salesforce customer, target object was QuickBooks customer. And we'd create these really strong bindings. And we'd do stuff like this, where we'd take source field, customer name is equal to, or we would just say like the target field comes from this static data or this column, right? It didn't really matter. So we could say customer name, and it goes to name, and then it goes into the name column inside of that comes from the name from the source object, but we want to trim it because we work with a lot of legacy systems, and for some reason they love having leading and trailing spaces. We've all worked on systems that do this, right? So we just wanted to make sure that it was trimmed. And then we wanted to have a create date. Now, maybe in the target system, that create date that open date is a required field. So we needed to be able to overwrite it, right? So we do create date, and if it wasn't there, we just do open date, and then we do our coalesce operator and just say datetime.now. That'll be close enough. When we're developers, we're just trying to get it done. We're trying to deliver an integration product. If they hate it down the road, we can always change it, right? So our task was to write something akin to an expression visitor. Now, at the time, I didn't know that expression visitor existed. So I ended up rolling my own, which you don't know what you don't know, but in retrospect, I feel kind of dumb. But I pretty much re-implemented an expression visitor. And then I needed to be able to handle any type of expression that we wanted to translate. Now, if you do like a dot starts with, a string starts with, an Entity Framework, what's going to do is translate that into a like statement. So we needed to do roughly that same thing. We needed to be able to say, okay, if we trim our source data, we trim the name from our source data, then we want to call ltrim rtrim inside of SQL because all this magic was happening in SQL Server, right? It was just cooking the SQL for us. Or if we want to do something like this, that's obviously an is null, right? That's pretty much the same thing inside of SQL. So we take that expression right there, that coalesce operator expression, and we would call is null instead, and we'd say create date, and then we'd even go so far as to be able to say datetime.now is actually get date inside of SQL Server. Which generally you should have your target system, your running system tell the SQL Server the date, not the other way around. That's another story. You get the idea, right? Datetime.now gets interpreted, and we can translate that if we wanted to into get date. So what we ended up with is we ended up with something that could emit nice-looking SQL. It didn't emit like too crazy a SQL, and it supported a large range of operations. It supported joins, and we could basically just join kind of like we do it in Entity Framework, but we could do it. Actually, we made it even more convenient for developers. We could do joins when we needed data from other entities, right? And we could send that in. It emitted nice-looking SQL. It was predictable because we had a set of tests behind it. We wrote a bunch of tests to cover it, and it saved developers thousands of hours over a 2 or 3 year period. Now that is money in the bank. That is not only money in the bank, that's delivery. That is being able to, like, when somebody would say, "Oh, we need a SQL generator," and we'd say, "Oh, that's no problem. Well, we can crank those out pretty quickly, right? Because we don't have to worry about stored procedures." And the best thing is that we could attach all this sorts of logic under the hood to say, like, well, we actually need to do these other transformations, right? We need to make the platform aware of those relationships. And we could do that because we would just run a bunch of extra SQL under the hood as part of this thing. It would all be wrapped in a transaction. Now, down the road, we found problems with this. We've actually moved on from this. But at the time, It was super powerful, and it saved it allowed us to deliver software really quickly, and it saved us a lot of money. And it saved, best part, developers didn't hate their jobs because they weren't writing stored procedures. So that's my real world example. Let's talk about maybe some closer ones. Maybe if you're an ASP.NET API provider or something like, you're an API provider writing an ASP.NET. So let's say we want to order by a string, not a string property, but literally give it a property name as a string as opposed to giving it like an expression, right, at runtime. So we maybe want to do something like this, where we provide an endpoint where we want to say, oh, if you want to order by the data that you want to get back, maybe you can just provide this parameter, order by equals name. Now, if you like OData, you could always install OData and you kind of get this for free. But if you don't want to do that or you wanted something more custom, you could do something like this, right? If this is the goal, this is the goal. But it's not like you're going to have a case statement where you say, oh, if it's name, then order by C into name, right? I mean, you might, if you didn't know you had expressions, you might actually do that. I've done stuff like that, and it works, but you could save yourself keystrokes. Let me show you. We could do something like this. We could roll our own this thing, right? And it's really useful. So our solution is to cook an expression. So our goal is to get to this LINQ query, right? Where we say order by, and we want to go c.name. But we don't want to do that case statement because maybe there's 1,000 properties. We don't want to write a switch statement with 1,000 things. So this is roughly what it might look like. So we've got it takes our iQueryable, so it takes our queryable expression, and then it takes the property name or field name if you use fields, and then you can give it a bool to say if you want it to be ascending or descending, right? You could also do it where you have order by property or field descending, right? You can have that implementation. We'll stick with this one for now. So our goal is to cook our expression and then apply it to our iQueryable chain. So we're going to take our C to C.name. This is the goal. This is what we need to bring out of this. So in our method, we need to capture the type of T, right? We don't know what type T is. We just want to know that we want to order by something on type T. So we capture that element type. And then we say expression.parameter, and we capture that type that represents the parameter to the expression that we're cooking, right? That represents the sole parameter to the order by clause. And then we can do this expression.property or field. There's also expression.property. Property or field is pretty useful, though, where you give it a thing, an expression to say this is the instance we want to find the property for, and here's the name of that property. Now, the cool thing here is if that line doesn't find a property with that name, it throws an exception. So you can always handle that and say, like, invalid order by, or just ignore the exception and let the query go through, right? You have that choice. And then you cook up expression.lambda. You give it your property, that's the thing, that's the body of the expression, and then you give it your type of T, or the parameter that you've wrapped in your type of T, that's the parameter, and then you've created C goes into C.name. It's the same thing up there. Pretty awesome. So remember, this is our goal, so we need to do just a few more things because our goal is to call this method. We need to call the order by method on the queryable static class. So in order to do that, we need to use a little reflection. This is where it gets a tiny bit hairy. So this is what it looks like. So we need a method name. So we have order by descending. Since we've just said we just have a parameter inside of that thing, bool ascending. We say if ascending is true, then just do order by. Otherwise, do order by descending. And then this is the expression.call. This is where the part where I tell you that this is like, you need to kind of look at the expression API if you've never used it before and experiment with it. Because this is kind of nasty to look at, right? Like I could describe to you in great detail what this is. It's just a type signature for a multitude of methods that are available to represent your expression. But going through it quickly, we need to capture the order by or order by descending method on our queryable object. So we say, here's the type. Since it's a static class, we need to get the type of it so we can just look for that method. We need the method name. We need the type signature of that method because we're cooking it custom. We need the expression that we are querying for, and then we need our selector. The selector being the method that we cooked up right here in this part. All right? So, yeah, I'm not going to go through that because what I'm going to do instead is show you in Dotnet Fiddle. Well, I'm not going to show you, but I'm going to show you that it exists. So, order by property example, I have a Dotnet Fiddle that does exactly that. Let's see. Post it on Twitter. Oh, I have the wrong text. Order by string prop name example. You can look at that. And if you look at that on look at that here. This is just a .NET Fiddle. Zoom in a little bit. And what I have here is just giving it order by property or field name. And what it'll do is write this set of employees in order. You can see we have Gary, Spencer, Michael, and Amy. So when we run this, since we called order by property or field name, we get Amy, Gary, Michael, Spencer in order. So that's pretty cool. And this is attached. There's a link to this that's attached to a paging example I did in ASP.NET, so you can actually see it end to end. You can actually download, look at this example, and see the whole thing. It's a few years old, so it will probably compile, but you'll get the idea, right? Because you'll see the whole thing. You'll see it from ASP.NET all the way down to when you cook the expression. So pretty handy. All right, more real world stuff. How about your own rules engine or search filter system or whatever, right? You could see how easily it would be able to take that thing that I just showed you and just copy paste it into a where, right? And create some kind of rules engine. So let's do that. Let's do that right here. So let's define something called a rule. And this example is a little bit rote. So what we basically want to do is represent a binary expression, but we want to represent this in a data structure of some kind, because we want to store this, or we want to be able to take from some JSON and deserialize it into something that's meaningful to C#, and then cook an expression with it. Well, you can do that very easily with expressions. So we have our rule. It says, given this name of this property and this operation or operator, and this value, we want to say, oh, name is equal to Gary, or hire date is greater than 1/1/2016, stuff like that. So we do that. We define our data. We either deserialize it from JSON, or we can just hard code it for this example. We have our name, operation.equal, name equal to Gary. Hire date equal to date time, right? So then what we can do is cook a binary expression. And just to break this down very quickly, what we need to do is take these rules essentially and translate them into an expression for each of these things. So we say we're going to capture the property of that parameter. We know the parameter coming in is going to be in a type employee. We're going to capture that property. We're going to grab the property name. We're going to take the constant value, the right side of our binary expression. We have our left, which is our property. We have our right, which is our constant. And then we know that our rule, our operation rule, is either equal or greater to, greater than or equal to, or greater than. We capture that and we call this called make binary. And what it'll do is we'll make that binary expression for you. And then we just set it to the binary expression that we declared up here. We just set it to null, if it's set to null, we just set it to that. Or we create a new binary expression where we essentially pass in and also. So we create a chain of binary expressions depending on the rules. If you look at the code under the hood, if you looked at this expression under the hood, if you declared it like this, you would see that this is just a series of binary expressions that are all operating on each other. And so this is what this becomes. You've got your E, you've translated your rule up here, you've got name equal to Gary, and hire date equal or greater than 1/1/2016. Pretty cool. And I have an example here too. We'll tweet that out. Click. Rules engine example. Tweet that out. Pretty sweet. Awesome. And then if I will show you real quick, if I run it here, so we've got our same set of employees, and we have our rules right here. So we're looking for name, Gary, hire date, 1/1/2016. So we've taken these rules that we've declared as data, and then created an expression down here to actually cook that up and then use it, and we have Gary 1/1/2017. If you change that to Amy and reran it, I don't remember what her hire date was. Her hire date is not that, apparently. We run that, and do we have an Amy record? Oh, we don't have an Amy record. Now we do. There we go. Now when we run it, now we get Amy. So what you've done is you've just declared some kind of way to represent an expression inside of data, and then you knew how to use expressions because you went to this awesome talk, and you were able to translate that and make your own rules engine. Now, there's a bunch of rules engine implementations out there, right? So that's nothing new. But now you can kind of understand under the hood what's happening, and you can tweak it if you want. We actually for years ago, we had a rules engine. And I said, this is not sufficient, so we're going to make some changes to it and make it better. Because I knew at that point enough to know how to make it better. because I knew expressions, or I practiced with them long enough to know them. There's like a multitude of things that you can do. So let's talk a little bit about expressions versus reflection. How many people are moderate to heavy users of reflection? Okay, me too. I love reflection. It is one of the greatest parts of the language and parts of the CLR. I love reflection. So expressions are, you can think of them as a nice abstraction over reflection. But reflection is, in theory, it's more powerful, right? You can use it, you can actually emit the IL to actually like run and create these methods. Expressions make it really convenient to do that, so you don't have to do that. Reflection is also can be considered if you're just reflecting on, if you're calling get value on some object, you pass in a property name and it gets the value. That's really slow, or at least that's what developers say. Expressions can kind of speed that up because what you can do is you can take that reflection, cache a delegate from using expressions. You can cache a delegate. You can compile one in memory and then reuse it. And expressions, once they're compiled, they are just as fast as they're virtually as fast as a method that you would declare in line. So expressions can be really fast. Reflection, used to solve very similar problems, can solve them a little slower, but I use them in tandem, right? I use expressions mainly to create libraries for developers to use that are really convenient, and then reflection under the hood to do all the really magic stuff, right? So really just depends on your use case, when you would use one or both, right? Or neither in that case. There are some dragons. Here be the dragons, right? So expressions are not perfect. They are not a perfect abstraction. And one thing about abstractions, they're great, but they leak. Expressions are not perfect. For example, how many people love the question mark dot operator that was introduced, the last C# version? That thing is awesome, right? That thing is great. You can't use it in expression because expressions came before that feature was available. So if you actually tried to declare an expression with the question mark, it says you can't do it, and it won't compile. And the reason you can't do it, it's a good thing. Imagine if Entity Framework 6 had to go back and refactor all their code just to be able to use that question mark thing. It sucks a little bit, but it's actually a good thing and it doesn't support it. But it also, you got to understand that the C# compiler does magic. It does a lot of magic for you. So let's take these expressions. Finally, something a little different than the two upper examples. So we've got combined strings. It's just a reimplementation of string.concat, right? Where we give it a function where we have two strings, and then we return on the other end those strings concatenated, right? So if we do the top one or the bottom one, doesn't matter. They don't exactly look like this when you look at them as an expression. Let me show you. If you try to do this, expression parameter, string 1, string 2, and then you did this make binary, and you said, well, that's an additive expression, right? Expression.add string 1 parameter, this will throw. And it will say the binary operator add is not defined for the type system string as system string. And you're like, well, what? I just did that. What's this? What's this that I just did? I literally just used it. Because under the hood, C# is doing magic for you. The compiler is doing magic for you. This uses string.concat. If you inspected this expression under the hood, it's not a binary expression. It's a call to string.concat, right? So it's not always the case where you can take, and this is just a very narrow set, but you have to be aware of it. It's not always the thing where you can just take this, look at it, and say, that's a binary expression. It doesn't always work like that. For the most part, it does, but C# does magic for you. Conversions have to be handled explicitly. This is kind of annoying, really. But like if you have an expression that takes a function or that has a parameter that takes a parameter of a specific type, let's say actually if it just takes object and you try to pass in an employee object expression into that, it will throw an error. You actually have to convert it to object because when you do that, what is happening is under the hood, C# is actually like casting. It's doing a cast to cast it to object, right? You're just not aware of that because you don't have to be. But casting and conversions, for the most part, have to be handled explicitly when you're cooking custom expressions. So you'll find that out. As you're messing with expressions, you will find out the limitations pretty quickly. Pretty fun. So how to start? What do you do? Well, I'd start by experimenting. And my favorite tools to experiment are LINQPad or Google. I use Google to look up expression stuff to this day when I need to. Don't ever memorize. Albert Einstein said, don't ever memorize anything you can just look up, right? I do not have every expression dot tight signature for all those methods. I did not have them all memorized. That just would not be practical. So I usually experiment. I will use LINQPad or I'll even use that .NET Fiddle, which is a good tool for things like this that make it really easy for you all to run it. For experimenting with the expression API, I'd use LINQ or even Visual Studio Code or something like that. And just do what we do best, use IntelliSense. Right? No shame in my game. I'll tell you, I use IntelliSense to discover stuff about expressions when I use them every time I use them. Right? Use your tooling. Your tooling's there to help you. And most importantly, did I mention experiment? You should experiment, right? That's just the bottom line. Like, take those examples that I've had for you. My previous time I gave this talk, I didn't have those examples. And I was like, that would be super helpful. That's super cool. Now you can click and, run expressions all day. Really awesome. At least in my opinion. So that's the end of my talk. If you have any questions, please see me afterwards. And this is not the end of our conversation. I'm going to fly home tomorrow, actually. And if you have a question, just reach out to me at Schneidenbach is the best way to reach out to me. So it is a pleasure. It has been a pleasure to be at NDC Porto. I have had so much fun, and you've all been very gracious. So thank you very much. Have a great rest of the conference.